Hello and welcome back. In this lecture, we learn about a U-tube manometer that is used for pressure measurement. In video 20, we discussed about a piezometer. A piezometer tube is a simple device used to measure pressure of a fluid. In this device, pressure is measured as height of a liquid column. However, to measure high pressure of a low-density fluid requires large tube length. Also, when measuring pressure below atmospheric pressure, it sucks air into the tube. Such issues can be avoided by a modified design of piezo tubes into a U shape, and using a manometer fluid. A simple configuration of U-tube manometer is discussed next. A U-tube manometer has a U-shaped glass tube, filled partially with a manometric fluid. Such a configuration can be used for pressure measurement. Consider a U-tube manometer connected to a point, A, in a pipeline, where pressure is to be measured. Let the density of fluid inside the pipe be ρ1 and density of manometric fluid ρ2. Depending on the pressure inside the pipe, the manometric fluid balances the height of its liquid column. Let H1 and H2 are heights of liquid columns. In order to find the unknown pressure at A, we can identify a convenient horizontal plane where pressure forces balances in the U-tube. Let C be this plane. We can derive two equations for pressures at C and C' in terms of fluid densities and heights. We know that for a stationary fluid, pressure is same at same horizontal locations. Equating these two equations, we can solve for the unknowns. For example, consider a manometer connected to a water line as shown in figure. The manometric fluid is mercury. In this configuration H1 is 20 cm and H2 is 40 cm. Find the pressure at point A inside the pipe. In order to solve this problem, consider pressure at C and C'. We can derive two equations from this consideration. Since the pressures at C and C' are same, we can equate these equations to find out the unknown. Consider another example. A U-tube manometer is connected to two pressure line A and B as shown in figure. Calculate pressure difference between A and B. In this problem we can find a pressure equivalence at point C and C' of manometric fluid. The pressures at C and C' can be related to densities, heights and reference pressures above on it. Equating the pressures at C and C', the difference in pressure can be found out. Consider a manometer used to pressure difference at locations 1 and 2 of a pipe through which water steadily flows. The manometric fluid is mercury. The height of mercury column is 1 cm. Calculate P1 minus P2. We will solve this problem in class. Hope you understand the concept of a mercury manometer. Thank you for listening. That